Hello, everybody. I'm Aditya Patwardhan, and I'm a senior developer on the PowerShell team. I have with me today Travis Plunk, who's also a senior developer on PowerShell team, and we'll be presenting our talk for PowerShell Summit called From Pull Request to Release. So to give a brief overview of what we'll be presenting, first we'll be discussing about the complexity that we have, and we'll talk about how we reduce the complexity at each step by talking about what we did in the PowerShell CI pipeline. Then we'll talk about what tools and processes we use for the release pipeline and all the tools that we developed along our couple of years of improving the process. And then we'll share the learnings that we had over the journey. So I'll hand it over to Travis now for the few first sections.
So let's talk about the complexity of our system, that this PR release system. The flow of change. The first thing you do when you want to make a change is you fork PowerShell repository if you haven't already. You introduce or commit a change in that repository. You test it locally, and then you open a PR against our repository, our fork of the repository. The next step, what happens automatically is we run CI. We build and test major OS platforms. We run packaging tests, including MSI on Windows. We have SSH remoting tests. We run a credential scan and a code factor static analysis against the code. Once that is merged, then a daily scan is going to be run against it. We do several things, and some of them are against your commit, and some of them are just things we need to check. One thing we need to do is check for a .NET update. And then we build and test on GitHub master. We do some more complex tests and longer testing than we do on SCI. One example is we enable tracing that .NET needs to analyze for bugs in .NET. And it just takes longer to run that, so we run that in our daily. And then dependent bot updates dependencies daily. It automatically submits PR. We'll talk about that in more depth. And then monthly we release. We build and sign all packages. We test on all platforms. We'll get into more detail on many of these. We run even more compliance checks. We generate a change log. We do that automatically, and then we publish to GitHub. And then we have many more publishing checks, publishing steps. We go to Docker, the Snap Store. We have Debian packages. We go to the Windows Store, and we have our MSI that is released. So let's talk about the different types of release we have. We have preview releases, which are done monthly, and they're done off of our master branches. These things are like currently they're 7.2.0 preview X or preview 4. Then we have a stable release. Our current releases for those are, well, they have all applicable. We backport applicable bugs, fixes. Security fixes are always taken. .NET bugs and dependency updates. Specifically on security fixes, high and medium security fixes. Low severity security fixes are only fixed in the next release. Then we have the long-term stable or LTS branch. Basically the same type of updates are done here. The bug bar here might be a little different, but basically the same type of bugs go here. Any comments on that, Aditya?
Yeah, one thing I would like to add over here is since the feature set for 7.0 and 7.1 could be different, the fixes and backward of bug fixes could be different. So it's not necessary that everything that goes in 7.1 will go in 7.0. So though they are similarly structured, there is some extra work in determining what goes where.
Yeah, and on that note, also like the bar to go into an LTS might be a little higher, so we might take something into stable release and not take it into LTS because we want to give it some time in stable to figure out if it's actually stable enough to go into a long-term stable branch.
And we try very hard not to take any breaking changes unless it's a security issue. So to guarantee compatibility when you get updates every month.
And for security issues, we take the we are solely responsible for triaging those issues. Breaking changes go to the committee and are triaged privately, and then we make security fixes as a release is made, and then backport them to the master branch. So the next thing we'll talk about is the CI pipeline. One of the major things is to execute functional tests. We execute functional tests on Windows, Linux, and Mac OS. We have about 10,000 tests altogether. To merge, every test must pass. And you must add tests for new code. We do have a few tests that rely on connectivity, and the maintainers will rerun those tests for you. But the test must pass before we merge your code.
Most of our tests are in Pester, but there is a small set of tests which is in XUnit. But most of our test collateral as well as infrastructure is in PowerShell.
And there's only a very small amount of tests in XUnit tests. XUnit is appropriate when you're doing unit tests versus.
Yeah.
Then we have packaging CI. Most of these tests are against Windows. We test the Windows MSI that we release to you. We run this on a matrix of our architecture and our release type. So this is basically, you multiply these together. You have x86 and x64 preview and stable. This gives you all these combinations, and preview right now is only tested on x64 though, because the pipeline has a stable release already installed, and the juggling of uninstalling the stable and getting something to work is a little bit hassle. And we have all the equivalency classes already covered. We cover x64 and we cover stable on the x86 variant, so we're not really that worried about it at this point. We may add it in the future if it becomes a problem. And this test is only ran when we detect a change in some of the files affecting packaging. That way we don't waste any of our CI time, the compute time needed to run all of these tests if the packaging code is unaffected. Coming very soon, we will start building the Debian packaging. We should add tests in the future after that. It too should be separated out if we add tests. Building alone is fairly cheap. But We added those because we're unified, and we'll talk about that more in detail on another slide. We have SSH remoting test pipeline. This ensures that SSH is working with the latest changes on Linux. The future work, we should add this on Windows. Actually, we also noticed that it has a tendency to hang. We should investigate those hangs and figure out why, if it's a bug in the test side or the feature side. It also filters to the remoting area. That's probably why the hang has not been a problem, a significant problem, but we should investigate it. And then we have static analysis, code factor style checks, credential scanner. We make sure credentials aren't introduced into the code. We have markdown link validation. This makes sure like a link isn't a 404 or just, a server that doesn't exist. And then we spell check our markdown. Any comments?
No.
And next we'll go to the release pipeline. I'll hand that over to Aditya.
So now now that the change has got merged into GitHub master, now we'll be talking about what happens to that change once it goes into the release phase. So first, I would like to talk about the branching strategy that we use for managing a release. So as you can see, we have two repositories over here. One is the GitHub repository, and we have a mirror in Azure DevOps. We use the mirror for doing all the release work. So when you are making a change, you open a pull request, which will run the CI tests. It will have a code review done. In the meantime, there can be more things that will be checked into GitHub master, but that should not be a problem because when you merge, we always merge to after rebasing. So we constantly keep on mirroring the changes from GitHub master to our private repository in Azure DevOps to keep everything in sync. Now, eventually the reviews are done, the change is approved, and then the maintainer goes and merges the change back into GitHub master. In the meantime, more mirrors could happen, they might not happen, depending on how much time is required for the change to go and get merged into master. So more changes happen and eventually we decide it is time to make the next release. And then we do a mirror and snap a branch from the private repository in Azure DevOps for doing the release. We add in more commits on the release branch, like for the change log or any test failures that might happen while running on the broad set of platforms. There might be more things that are getting checked into GitHub master, but they won't be picked up for this release and they will be released in the subsequent releases. Once everything is good, the changelog looks good, the tests have been fixed. We take that commit, create a tag for that commit, and push that tag back up to PowerShell repository on GitHub. We push it upstream essentially. And now we have some changes that we did in the release branch, which are not there on GitHub. So we have to take these changes back and merge them into GitHub again. So now everything is consistent. All the changes that we did are back on GitHub, and we have no need for having the release branch. And that's why we go ahead and delete the branch. So when we are making another release, we start the process over again, do a mirror, snap off a branch, and continue with the release. This is for previews, but for stable and LTS, the branching strategy differs a bit because GitHub master is going to proceed and become the next preview once we GA a particular release. So for example, once we release say 7.10, the master branch on GitHub becomes the first preview for 7.20. Now the code for that progresses. There could be more features added. for 7.2, which might not be backported to 7.1. So we have kind of two trains that we have to manage for shipping the packages. So for that, as we said earlier, the same mirror repository that we have on Azure DevOps, we have a tag that is available for the previous release of the 7.1x branch. In this example, it's 7.1.3. So what we do is we create a branch of 7.1.3. So as you can see over here, there are still changes getting merged into GitHub master, which may be backported later. And some of them will not be backported later. So now we create a release branch of the 7.1.3 tag, name it 7.1.4, and add additional commits for SDK updates, security fixes, change logs, updating dependencies for the packages like NJSON schema or PowerShell native and so on. Once that is done, if there are any backport changes that we need to move from GitHub master, typically they are infrastructure changes or a specific bug fix which is considered important enough to take it down to a previous release. We bring them back onto the release branch. Once this is done, we release our extensive set of tests, and eventually we get to a point where everything is working fine. Change log is reviewed and updated, and we are ready to release packages. We tag the release and push the tag back to PowerShell repository on GitHub. Once this is done, we bring just the changelog over. The difference between the preview releases and the stable and LTS releases is we do not bring any other changes over, like test fixes and stuff, because the code in GitHub master is for 7.2 preview releases. So the fixes might not be applicable. So we keep those fixes in the 7.1.4 branch and just bring the changelog over so that everyone can see the changelog by going to GitHub. Once this is done, we don't need the release branch again. So we just delete the branch. And for subsequent releases, we would fork off a branch of the 7.1.4 tag to make the 7.1.5 release. Travis, do you want to add anything over here?
Just one comment. I don't think we had our animation perfect. The changelog commit would have existed before we pushed the tag. So we would just be porting over an existing commit that existed when we created the tag.
OK. So it doesn't really matter what the order is, since the tag already contains that commit. Now we'll be talking about all the tests that we run for every release. So when we are going to do a release, we run about 220,000 tests over 20 platforms. Currently, the pass rate for those tests is about 99.95%, which still leaves at around 100 test failures, which is an average of 5 test failures per platform. We are trying to get that down to 0 reliably to make our job easier, because every time there's a test failure, we have to go ahead and triage to see if it's a newly introduced issue or a test issue or something that has already known problem. Remember that whenever we are doing a release, we are typically doing one release for preview, one for stable, and one for LTS. So all the time we save for doing test triage, test failure triage, is going to be very beneficial because all the failures are basically multiplied by 3. So we mostly leverage Azure DevOps hosted agents for doing most of our tests, but there are some cases where some platforms are not supported in Azure DevOps directly. So we create Docker images with some pre-installed testing tools, and we have those images available, and we use containers as hosts in Azure DevOps to run tests on them. For things that do not have containers, like running tests on Linux ARM32, we have a Raspberry Pi device which has an Azure DevOps agent installed on it, and we run tests on it using Azure DevOps, the same pipeline that we use for running tests. There are some OSs like Windows Server 2012 R2, which we currently provision directly in Azure using AZ commandlets and ARM, and then install an Azure DevOps agent and run tests on them. So we are hoping to move to using VM scale sets backed by Azure DevOps agent pools. The reason we are hoping to do that is we can create a virtual machine image, which has the prerequisites installed on it, which would reduce our provisioning time for getting the machine ready to run the tests. And then we can just reuse this image and create multiple copies of, multiple virtual machines from that image. And since it's a scale set, we can always scale it up and scale it down as the requirements are when we are running multiple test passes at the same time.
It also helps with the like the Azure VM machines right now. When we need them, we create them manually. It would help, like if the image we have now is adequate, it would help completely automate that, so we don't need to manually create the machines and destroy them.
Yep. So now I'll be talking about the various tools that we developed over our journey of a couple of years, making the release process much more efficient. So we use a mix of open source tools and processes and tools that we have developed mostly in PowerShell to increase the efficiency. So across the board, we use YAML for our pipelines, and most of the scripts are in PowerShell. So the reason for you having everything in YAML is to treat infrastructure as code. So when we have 3 branches that we need to manage, the infrastructure could be different. The number of packages that we build and release could be different for each version. For example, we do not release the global tool for preview releases, whereas we don't release the package on Windows Store for the LTS release right now. So if we have the release pipeline as a visual build, we would have to constantly keep on switching on and switching off things depending on what we are trying to release, which makes it very much error prone. And we have made mistakes before where we forgot to release a package, which we had to go ahead and manually release later. So to avoid that, all our infrastructure for build pipelines is in YAML and PowerShell scripts. Now, another benefit of that is since we have it in YAML, all the steps, including the manual steps, are in YAML. So we don't forget anything. The YAML also gives us an ability of having approvals. So one of the maintainers could approve and make the release proceed. Having everything in YAML also gives us version controlling. So if we, for some reason, if we make a mistake and the release pipeline is wrong, we can always roll back the changes. And as I said earlier, we can always release it for multiple older releases. After we release 7.2, which is going to be an LTS, we will be having 4 releases going forward for 7.3 previews, 7.2 and 7.0 LTS, and 7.1 as stable. Having this also makes it easier to backport infrastructure changes from GitHub down to the other release branches. So we have, as most of you might know, we have multiple repositories under the PowerShell umbrella. For example, the main PowerShell repository. Then there is a repository for PowerShell Get. We have secret management, secret store, PowerShell native, and so on. So all these components are combined together when we release a PowerShell package. Well, not the secret store and secret management, but there are dependencies that, so there are common tasks that are required for running the releases for these repositories as well. And the way we run these tasks is by creating YAML templates, which we share across all of the repositories, and also other organizations can use it. There are other Microsoft open source projects which are already using this to run the same tasks, which are kind of common, like compliance checks, signing, credential scanning, etc. So over here, what we do is we leverage the multi-checkout technique from Azure DevOps, where you check out another repository in addition to your repository under test. And then when in your YAML, you can reference the other repository and inject the templates into your pipeline. So what that does is there's only one source of truth. And whenever a change is made to that, it automatically updates everyone who's using it because it is injected back into your pipeline at runtime. So we have created an Uber template for common tasks or set of goals that we have to do. For example, when we want to run some compliance checks on an assembly module, we have a bunch of tasks. That list changes a bit for a script module or for CI build. So we have these Uber templates created, which is the only thing that you need to call from your pipeline and everything and pass the appropriate parameters. And all the required tools are automatically run for you. To check out these templates, you can go to github.com/PowerShell/compliance and have a look at these templates. The templates over there are specifically for use by internal Microsoft projects. You can use them as reference, but I do not recommend them using them directly. We also use GitHub Actions for making some changes directly on GitHub repositories, like checking for whether a new .NET SDK is available. So if we have a GitHub action which runs daily, which calls a PowerShell script, which checks if there's a new .NET SDK available. If it is available, it updates all the CSProc files, all the metadata files, and the packaging files needed for consuming that new release, and then opens a PR against the master branch. Since a PR is created, it automatically runs all the tests, all the CI tests, to make sure that the changes are not breaking anything. Once that passes, we can merge the PR after reviewing, and then it kind of automates a bunch of things that we used to do manually, and keeps us at a good pace in accepting newer changes specifically from .NET. We use a similar technique for automatically releasing updates to our homebrew formulas for macOS. So we look at the latest release metadata and open up a PR in for homebrew to publish the homebrew formula. We extensively use Dependabot to update dependencies in all the CSProc files that we have in our project. So it checks for dependencies on a daily basis, and if there's an upgrade available, it will create an PR for you, and that's how a PR looks like, which is created by Dependabot. In this example, it has created a PR for updating the NJSON schema NuGet package from 10.3.6 to 10.3.7. So another good feature of Dependabot is if before we merge this PR, if 10.3.8 is released, it will reuse the same PR and make the required changes to bump the current version from 10.3.6 to 10.3.8. So it does not create multiple PRs for the same thing, but it will replace the code in this PR. There are options for doing manual changes. If there is like a test failure because of this, you can push changes to the same pull request. Or if you don't want to accept the PR, you can just close the PR. Dependabot can also be configured to assign labels, like the label that we have added over here for CL build packaging. We'll talk about labels very shortly and why we use them. So we use labels for creating the changelog automation. Earlier, when we used to create changelog, it was a manual task. And considering the amount of changes that go into PowerShell for every release, it was very, very tedious. So what we decided is enforcing assigning a particular set of labels whenever a PR gets merged. So all the labels that start with a CL dash are for the changelog. So for example, over here, we have two labels called CL breaking change and CL packaging. So these labels are used for creating sections in our changelog and adding what pull requests get were merged with that labels. So all the sections get filled up with a list of things that were changed for that section. In addition to that, we also use the MD spell tool, which is a NPM package. Also, Markdown link check tool for checking all the links that are in all the Markdown files. For making sure that the changelog that is created is correct and it has valid links and no typos or anything. Some sections in the changelog tend to be very big, and it might not be always useful to see all the details. So we use the summary tag, the details tag for summarizing. So for example, on the right, where you see kind of a black triangle, that's a clickable, collapsible section for seeing all the build and packaging improvements. And we also have a summary of what was the main change that we did in that release, which was, in this case, bumping the SDK, .NET SDK to 5.0.4. So this helped us a lot by saving a bunch of manual work for every release. And it obviously, everything adds up. Another interesting thing that we encountered recently is NuGet substitution attack. So in this case, as you can see, this is a screenshot of the NuGet.config file from PowerShell repository. Since we take pre-release bits from .NET for GitHub master, we need to have two feeds in our NuGet.config, one for .NET and one for NuGet.org. So the issue over here is if someone publishes a malicious package to NuGet.org with the same name as what we expect for a package from .NET, when restoring the packages for the project, NuGet.exe unpredictably chooses a package from either of the feed. And that can cause a problem because a malicious package can get included in the product. So there are a couple of ways of mitigating this issue. One is to use a single trusted feed if you can. In our case, we could not use that. And also another way of doing it is only use packages whose namespace is owned by a trusted entity like a Microsoft, or you can reserve your own namespaces on NuGet. What we ended up doing is before building, we replaced our NuGet config that you see over here with another NuGet.config file, which has only single private single private feed, and that private feed has other upstream feeds added to it. So whenever we download packages, we download it from the private feed, and that private feed will fetch packages from all other dependencies that we have. If there is a package conflict, it's up to us to resolve where we get the package from. So that makes it, that gives us control to making sure that we are not getting in malicious packages. Jumping over to another set of changes that we did recently is we used to have a lot of packages for Debian RPM. For example, we had a separate package for Ubuntu 16, a separate package for Ubuntu 18, and a separate package for Ubuntu 20, and also a separate package for Debian 8, Debian 9, Debian 10, and so on. So we discovered that we can use the technique for falling back dependencies while creating the deb packages for something like libicu. And using that, we can create a single package, which is mostly the same and can be installed on all the platforms that we support. Similarly, we have unified the package for RPM as well for CentOS and Red Hat. The main difference between the packages is we have dependency on libcrypto and libssl for libmi. Since there are different versions on each version of the OS, we create symbolic links. So currently we're creating symbolic links while creating the package. But what we are doing now is use a post-install script to dynamically create the symbolic links when you're actually installing the package. So that makes it easier for the package to be a single package which can work on all the supported platforms. The symbolic links are only required for libmi, which has limited support, and eventually we will be getting rid of that. So now I'll hand over to Travis to talk about the learnings that we had over our journey of improving our infrastructure.
So learnings. So our biggest learning was automate everything we possibly can. Everything that's manual takes time away from developing new features or makes it take longer to release something, and we've already talked about how many releases we have. So tools, we talked about how we automated changelog generation. Instead of doing manual spell checks, we automated the spell check. We created a script to update the .NET SDK and packaging change rather than someone spending a day or two doing that. When we found Dependabot, we used that to update our dependencies. We actually had someone from the community suggested this, and I investigated a couple of options, and we went Dependabot before it was acquired. The GitHub actions to update and homebrew formula. Those have been very helpful. We don't have to spend manual time to go update our brew cache is what we were using before. Now we publish formulas to you that just GitHub actions open the PR for us when we have a new release. Let's go over to processes that we've already implemented. So we implemented a single build for all platforms. Previously, when we had multiple builds for each platform, we have some packages that actually compose things together. So we had to manually compose those things together if the builds are separated. Or I think in a midterm we had one build that we had to go enter the build numbers for all of those things so it could pick up the pieces from them. We had to automate signing. At this point that seems obvious, but it's something we had to do at one point. Automate all the compliance checks. We're at a big company with a lot of compliance rules, and automating those things took quite a bit of time. But you should do the same thing where you are, automate them. Where we can't automate things, we put placeholders in to tell us to do them. We don't want, let's say, Aditya normally does something and he's out. We don't want to forget it because our SEP doesn't. So our pipeline tells us to do our manual steps. We have a GitHub draft. We create a GitHub draft automatically that uploads the files and creates all the SHA hashes. We still have some work there to completely automate the draft, but we've done that part of the work. So plan work. PR creation for various package publishing steps, like we need to, WinGit has a step for creating, for installing PowerShell, we need to go create that PR. And there's various other places. Auto triggering dependent pipelines, like we have PowerShells, Snap, just a ton of them. I can't remember. But over the course of this, it used to take us a week to release this, and now we're down to about 6 hours to go from build to release. So hopefully we can improve that time, but new things keep getting added. So That's one thing that I would also like to say. We went to 7 days to 6 hours, and we've added more package types to that.
Yep.
So infrastructure as code. So this makes shipping multiple releases simultaneously simpler and less error prone. We have YAML pipelines and PowerShell scripts that everyone on our team is familiar how to write and read PowerShell scripts. So if something goes wrong, we can fix them. There's things constantly changing around us, so things go wrong all the time. We have to make fixes. It's good that anyone on our team can understand what we've written and can fix it. And infrastructure can evolve because it's with our code. Our infrastructure for 7.2 and 7.3 can be different to meet the needs of the things we've added in 7.2 or are not there in 7.1. And as we make fixes, like let's take the NuGet substitution attack, we can go and backport those fixes back to previous releases. Standardize and share components. So by sharing components, like recently I made just a fix to help diagnose problems, and I made that in the shared components, which means every one of our projects that's using shared components, not just PowerShell, but secrets management and secret store, all get these changes to handle diagnostics when I made the change. So that's the next point before I even read it. Change once and update all. Testing. So this is another big learning. We test more often, test as early as we can. This is the shift left. Test all major platforms. So we want to test all major platforms, test broadly. We test all platforms on every release. We want to get to where we're testing all platforms as soon as we can. Strive to get to 100% pass rate, where green means go. We've gotten to 99.95 across that platforms. Hopefully we can get to 100, where we have, occasional failures that are rare, not. You saw the number, the 0.05% failure rate across 200,000 tests is not a small number of tests. We need to get that down. So now I'd like to thank you all for attending. If you have any questions, here are both of our Twitter handlers. I'm at Travis Plunk, and Aditya.
I'm at Aditya Patwar 13. So please feel free to send us a direct message, or if you want, file an issue on GitHub, and that definitely grabs our attention.
Thank you again.
Thank you.